we've got a situation here with two lenses, and they each have different refractive indexes. And then we're seeing virtual images of the candle in this photo in each lens. Explain why the images formed by the two lenses are different in size. Well, that's due to the refractive index being different. That's because one with a higher refractive index will refract more, and that causes the light rays to bend in a much greater amount in a smaller space, which means the image is going to appear to be larger on that one. I'm pretty sure I'll draw the ray diagrams to help with the explanation, as it says. And but essentially that's it. They're different refractive indexes, so they act like lenses with different radiuses of curvature. Now the one with the lower refractive index is going to have a further away, a wider focal length. So let's put it somewhere out here, quite far away. Remember, the object here has to be inside the focal length to produce an image that's virtual, which is what we're after here. And the lens with a higher refractive index, let's make it sort of around about here. Okay, and then let's go ahead and draw some ray diagrams. So parallel light ray is going to refract through the focal length, and you really should use a ruler for these ones and try and keep it in as close to scale as possible. And you're going to have one that goes straight through the optical center. You can see it doesn't spread out in a very fast way. That means in a very far way. That means these are going to meet relatively close. Okay, and that's where your image is going to be. Now this one here, your parallel light ray, is going to bend much sharper. Okay, it's still, yep, that's good enough. And then oh, hang on. Yeah, I haven't drawn this particularly well. It's going to be much sharper, but I was originally wrong with my idea. That just means it's going to be closer to... No, that's right, because the light rays, because the angle is much shallower of that bend, it's going to take them a lot longer to actually meet and cross over. Okay, I did have that kind of wrong. The further away you can see here, if I sketch a number of rays over the top, and still trying to make this quick, but the further away the focal length gets, the smaller and closer it's going to overlap this ray that passes straight through the center. So anyway, so that's the main idea. High refractive index causes greater bending, which means your image is going to be closer to the position of the lens, which means it's going to be smaller. So that's why they're different. Essentially, the one main thing is the different refractive index causes the rays to bend at different amounts, and then the images will appear to be at different locations and be different sizes purely because of that. So you can get a more comprehensive explanation in your answer if you really need to, but that's the main idea.